Hello and welcome to Web Math Academy and our new lesson on Newton's root approximation. Although some equations can be solved analytically, such as using the quadratic formula for a squared function with real roots, many more cannot. For these and for all higher order equations, Newton's root approximation comes into play. The idea is to choose an introductory root that you think is close to the real one and then plug it into Newton's equation. Out comes an answer that is even closer to the real root. Using this value, input it into the equation again and repeat the process. You will be surprised at how quickly you will come to the desired root, often out to 10 decimal places. So what is this Newton's equation? Well, it's quite simple. Right here, x new equals x minus the function divided by the derivative of the function. Here, x is the guess that we come up with. F of x is the function that we would like to solve, and f prime of x is the derivative of that function. This derivative is actually the slope of the line tangent to the graph of the function at x. This will be clearer with an example. Let's try f of x equals 0.1 x squared minus 1. Now this is a very simple equation, but it will help us to see how powerful Newton's approximation is. Again, it can also be used with many higher order equations. If f of x is 0.1 x squared minus 1, then the derivative f prime of x is simply 0.2x. Now, as a first guess, let's try x equals 10. Check out the graph to your left. Now, the blue curve is the graph of our function 0.1 x squared minus 1. And the red line is that tangent to the curve at x, given by a derivative. Where this line crosses the x-axis, value 5.5, that's Newton's first approximation to our root. If we plug this x1 value 5.5 back into Newton's equation, we get even a closer approximation, which in this case we can see from the tangent line crosses x at 3.65909. Now rinse and repeat. If we just do a few more iterations using these values, we will come up to our solution, which is 3.162, roughly the square root of 10. Let's verify this with our TI Nspire calculator. Here you can see I've already plugged in the values for the first two function roots. First equation uses x naught equals 10. And plugging this in, we come up with 5.5, just like we showed on the graph. And then when we put 5.5 in, we come up with 3.65909. Let's try the next one. We're using 3.65909 minus, and then our function is 0.1 times 3.65909 squared minus 1, right parentheses, and then divide that by the derivative, 0.2 times 3.65909 parentheses, enter, 3.196. So you can see after just 4 iterations, or 3 I should say, we've already come to almost the exact solution for the function. The solution, by the way, is roughly 3.162278, or the square root of 10, which can be easily verified with the quadratic formula. As stated before, Newton's approximation can be used for many more complicated functions, including trigonometrics, but we certainly don't want to solve these by hand. It's time for a TI Nspire program coming next.